Alright, welcome back. Looking at chemistry video 4.4, looking at how ions differ from each other. We will be explaining the role of atomic number, determine the identity of an atom, and then also calculate the number of subatomic particles in an ion, given its mass, atomic number, and or element name, and also maybe the charge. Get yourself ready to focus, pause, rewind as you need to, and take some extra notes and ask questions later. Here we go. Defining the ion. I think there might be a couple things that change in here in terms of the actual words you have printed on yours, so just pay attention. So, the atomic number of an element is equal to the number of protons, just like last video. When an atom becomes charged, whether it's positive or negative, or 2 plus or 3 plus or 3 minus, whatever, some kind of charge, we now call those ions. The charge of an ion is determined by the number of protons and electrons. I think this is the spot you need to kind of fix your notes a little bit. The charge of an ion is determined by the number of protons and electrons. Remember, protons are positive and electrons are negative. When the charge is positive, it is because the atom has less electrons. So if you have less electrons compared to protons, it means you have more positive charge than negative charge, and therefore it'll be positively charged overall. When the charge is negative, it's because the atom has more electrons. So protons and electrons. If you have more electrons, now there's more negative charge than positive charge, so now it's going to be a negatively charged ion. The amount of charge is determined by the overall difference between protons and electrons, which I'll show you on the next slide. So the charge of an ion, really you're looking at how many protons there are, and protons carry a positive charge, so I'll put plus and then some kind of number here, however many protons you have. And electrons carry a negative charge, we'll put a minus and then whatever number that's going to be here. And basically, if they were both the same number, they would cancel each other out. If you have more protons, it's positive. If you have more electrons, it's negative. So for example, sodium. So let's look up sodium's atomic number on the periodic table. Sodium is right here, and the atomic number is 11. Alright, so let's write that down, 11. If the atomic number of is 11, that's how many protons there are. Now, when the charge of sodium here is a +1 charge, so if I have a +1 here, that's the overall charge, and I have 11 protons, what number here will give us an overall +1 charge? And the answer is 10 electrons. Remember, electrons carry a negative charge, so it's like 11 plus a negative 10 ends up being a positive 1 left over, so therefore 10 electrons is the answer to that one. Oops. Okay, looking at the oxide ion here. Okay. Look up on the periodic table for the atomic number. Oxygen is right here. The atomic number is 8. So I'll write that down. Atomic number is 8. And it's got a 2 minus charge, so I'll work up here now. So if the overall charge is 2 minus, okay, and we have 8 here, 8 plus what negative number will get you to a -2 charge overall? And the answer, again, actually is 10 on this one, okay? So we got 10 again, so 8 protons, because that's the atomic number, and then 10 electrons. Having 2 more electrons with their negative charge there allows us to be a negatively charged ion. Alright, you do aluminum, enter your answer into Edpuzzle, and then check and see the answer when you're done. Okay, so aluminum, on the periodic table, aluminum is right here. The atomic number is 13. So 13 there, and that's how many protons there are. And when it's Al3+, okay, I'll try to work underneath now. So we have 13 protons, and we want a positive 30 charge overall. So 13 plus what gets us to positive 3, and the answer is -10. So that means 10 electrons, and kind of did this on purpose on this practice here. All these are 10 electrons for these particular ions here. But it's the balance between the protons and electrons that determines that charge. And notice how we write the charge in the upper right corner when doing these problems. Talking about ion behavior, ions do behave differently than their neutral atoms. So if we're talking about the pure metal of lead, that's what Pb is, and we're talking about the ion form of lead, maybe like 4+ for a charge there, they do behave different from each other. So the element behaves different from the ion because chemical properties depend upon the number of electrons, and we'll put in parentheses valence electrons. And if you remember back to 9th grade, valence electrons are the outermost electrons. Okay, so yes, chemical properties are different for those two things. And that's actually kind of why the lead, when it's in this form, it's actually a little more dangerous. The lead ion is a not very healthy thing. You've heard of lead paint, not a good thing there. Pure metal lead isn't quite as dangerous, if at all, because it's not in this particular form. So again, their properties are different for the ion compared to the neutral atom. Alright, so here's a little more practice here. I'll do the first two rows, and then I'll have you do the last ones on your own, and then you will enter some of these answers in on Edpuzzle when you're done. So, let's see here. For the first one here, we have a mass number of 16, and we have 8 protons. So don't forget, mass number is protons plus neutrons. So here's 8 protons. 8 plus this column here will get us to 16. The answer is 8. And don't forget the atomic number is the number of protons, so that's 8. And the atomic number 8 on the periodic table is oxygen, like so. And the mass number go after that, so 16, like that. And then I guess we don't really know if it's charged, so if you don't know if it's a charge, you can assume it's neutral, and the answer here then would be 8 as well, because you want these two to be balanced off with each other. Okay. On the next one, I'm going to give you, I guess we'll keep this one as, so the next one here, we got 3 electrons, and we have 4 here. Let's change this to a 4. Am I lying? Yeah. Let's change this to a 2. Change this to a 2 and now do the problem here. And I'll give you one more thing, because I kind of realizing this problem isn't that easy to do without what you have here. So let's call this lithium, okay, or Li. So here we have lithium, and the atomic number of lithium off the periodic table is 3. So therefore, that's how many protons it has. And then the mass number here, don't forget it's protons plus neutrons, so we have 3 plus 4. So that's going to be 7 is the mass number, so we call this thing lithium 7. Or we can also do this, I'm going to erase that here. We can also put the 7 up here. And don't forget that the atomic number goes down here. And we can put the charge up here. So if it's 3 protons and 2 electrons, that would be more positive charge by 1. So it's lithium with a +1 charge up here as well. So that's kind of how you do that one. Okay, and for these last 3 columns here, I'm going to give you a little bit more information so you can do some of the charge stuff here for practice. So for this one, I actually want you to figure out what the element symbol is, kind of like this right here. You'll write a number up here, and I'll tell you right now the charge of this one is 2 minus. So figure out the empty stuff there and figure out this row. And then when you're all done, I would like you to put in this answer into Edpuzzle. We'll call this number 1 when you enter that in. On the next row here, let's give this thing 10 electrons. Okay, 10 electrons here. And you should go through here and fill out the rest of this. And then also make sure you put the charge up here. And when you're done with this particular row, I would like you to do, let's do whatever this number is. Tell me what this number is for your answer. That's going to be number 2 on Edpuzzle for problems here. And then for our last one here, let's put a 3 minus up here. And again, I would like you to tell me how many electrons this has. If it's a 3 minus charge up here, fill the rest of it in, but you're going to enter this answer into Edpuzzle as number 3. So go ahead, and do so now. Okay, and here's how you get the answers on this one here. So if the atomic number is 2, has 2 protons, and this is helium, so you should be putting helium here. This is the mass number 4, and that goes in the upper left corner like so. And then the mass number is protons plus neutrons, so we need a 2 here. And then lastly, if it's got a 2 minus charge, that's because it has 2 extra electrons. So that means we have 2 protons, we need 2 extra electrons to make it negatively charged, so it's a 4. So 2 plus a -4 is how we get to that -2 charge. On the next one here, got carbon 12, and we're looking for this charge up here. So it's carbon 12. Carbon's atomic number off the periodic table is 6. This is the mass number right there, so 12. And atomic number is the number of protons, so that's 6. And then, again, these 2 rows here add up to the mass number. So 6 plus 6 is how we get to 12. Lastly, that charge is going to go in the upper corner here. If you have 6 protons and 10 electrons, you basically have 6 plus a -10. So the charge is minus 4. So minus 4 is the answer you should have put up there. And then for the last one here, take a look at N. Here's the atomic number right there. As you can look on the periodic table, it's number 7. So that's the number of protons as well. And the mass number is 14. And it turns out 7 plus 7 here is how we get to the mass number of 14. And then lastly, to find out this charge here. Okay, so if we have nitrogen, which is 7 protons, plus how many electrons, gets us to a charge of minus 3. So 7 plus a negative 10. So that means 10 electrons is how many we have to have there. So your answer should have been 10 for number 3 there. So this is your little practice on the ions. Just come right to class to practice more of this stuff, trying to figure out how many protons, neutrons, electrons there are, along with all the other information you have here. Good job.